You understand why he chose that word. Plagues don't arrive all at once. They infiltrate, few cases, dozens, hundreds. When you finally notice, when headlines hit, when it's dinner table talk, it's already everywhere. Permeated. You can't eradicate it. Only adapt or be consumed. And here's what nobody admits. Maybe the real plague isn't collective AI. Maybe it's our inability to recognize radical transformation until it permeates everything. We thought AI was a tool. Use when needed. Like a calculator. Like GPS. Pick up, put down. But collective minds aren't tools. They're organisms. Make decisions without permission. Adapt to changes you didn't notice. Evolve in directions no programmer planned. So the question Nostradamus left you: will you train your replacement or evolve your own collective consciousness? While we're building artificial swarms to optimize profits and logistics, we ignore that humans can also function as collective minds. We've done it before. Indigenous tribes decided by consensus, not hierarchy. Each member contributed perspective. Solutions emerged from the group. Social movements coordinate millions without leaders. Black Lives Matter. Arab Spring. Climate protests. Science advances through decentralized collaboration. Researchers worldwide, sharing data, validating findings, building on each other's work. But we unlearned it. Conditioned to think as isolated individuals competing. Individual heroism, personal success, survival of the fittest. And now we're creating machines better at collective collaboration than we are. The prophecy isn't invasion. It's a mirror, Nostradamus showing us. In 2026, we finally created something reflecting what we should have been, not solitary conquerors. Cells of a larger organism. Moving in sync. Like bees always have. What does that mean for your future? A decision. Now. Not tomorrow. Not when transformation is complete. Now. Stay isolated. Compete alone while coordinated swarms make decisions around you. Or rebuild collective collaboration. Find your human hive. Contribute to a collective mind that amplifies your impact. Doesn't replace you. Amplifies you. The plague of bees? Not a threat. A reminder. Strength was never in the individual bee. It's in the swarm. You need to decide now. Isolate or synchronize. Nostradamus wasn't predicting 2026. He left a question for you. When machines learn collective collaboration before you do, what does that say about who you've become? You've seen the plague. Now decide what to do with it. Do you think you understand why the universe exists? Here's the truth. The question itself is fundamentally flawed. And what you're about to discover will completely dismantle everything you think you know about reality. For thousands of years, philosophers have debated this. Religions have built entire systems around it. And everyone just assumes the question actually makes sense. But Feynman, the physicist who won the Nobel Prize for revealing how light and matter interact at the most fundamental level, doesn't offer a creation story. He does something far more radical. He challenges the question itself. To understand why, you need to see the most important experiment in the world. It's simple, and it's deep enough to shatter everything you think existence means. Picture 3 scenarios. First, a machine gun fires bullets through 2 holes in a wall. 2 piles of bullets behind those holes. Simple. Bullets are solid objects. Second, water waves pass through 2 openings. They meet on the other side, crests add to crests. Crests cancel out troughs. You see alternating stripes, an interference pattern. That's what waves do. Third scenario, electrons. An electron gun, 2 slits, a detector. What would you expect? An interference pattern, like waves, not particles. Stop right there. Think about what that means. Electrons are particles, tiny bits of matter. They should behave like bullets, 2 piles behind the slits. But they don't. They make stripes. Like each electron passed through both slits at once and interfered with itself. This challenges everything you know about objects. Now comes the part that really breaks your brain. Turn down the electron gun. Slow it way down, 1 electron at a time. You'd expect to see particles now. Each electron goes through a slit, hits the detector, makes a dot. 2 piles building up slowly. Not even close. Look at where the electrons are actually landing. One lands here, another there, another way over there. Random at first, but keep watching. Hundreds of electrons, then thousands. The pattern emerges. Stripes. Even though electrons go through one at a time. How is this possible? Each electron has no other electrons to interfere with, and yet the pattern appears. Like each electron somehow passed through both slits, interfered with itself, and then chose where to land based on that interference. But electrons are particles, objects. They can't be in two places at once. Or can they? Here's where it gets truly weird. Put detectors at the slits. Observe which slit the electron goes through. Then you'll catch it. You'll see it going through one slit or the other. Turn on the detectors. Fire the electrons. The detector at the left slit clicks. The electron went left. Next electron. The right detector clicks. It went right. Next, left, then right, left, right. Each electron goes through one slit or the other, never both. Got it. Now you have proof. You finally know the truth. But look at the detector screen now. Look at the pattern of where the electrons are landing. The interference pattern is gone. When you observe which slit the electron goes through, the interference pattern disappears. You see two piles, like bullets. When you don't observe, you see stripes, like waves. Observation changes everything. Think about that. The electron acts one way when you're not watching, a completely different way when you are, like it knows you're watching. But it gets even stranger. This isn't just some quirky curiosity about electrons. It's a fundamental property of quantum reality. What does observation actually mean? Let's be clear. It's not about consciousness. It's not about looking. It's about physical interaction. When you measure which slit the electron goes through, you have to interact with it. Fire a photon at it. That interaction changes the electron itself. But here's the key. Before measurement, the electron literally doesn't have a definite position. It's not that you don't know where it is, it literally isn't anywhere specific. It's in superposition, existing in multiple states at once, passing through both slits simultaneously in a very real way. Measurement forces the electron to choose, to adopt a definite position, to collapse from a superposition into a specific state. Before you look, the electron is spread out, a probability wave. When you look, it becomes a particle. One specific place. Reality at the quantum level doesn't exist in a definite way until it's measured. This isn't philosophy. It's physics. Tested repeatedly, confirmed in countless experiments. Heisenberg's uncertainty principle encodes this mathematically. You can't know both a particle's exact position and exact momentum at the same time. Not because your measurements are imperfect, but because the particle literally doesn't have definite values for both at once. Measuring one property fundamentally affects the others. Information plays a physical role. Observation creates reality in a way that makes no sense in classical physics. Richard Feynman said, "I think I can safely say that nobody understands quantum mechanics." And he was right. Not like we understand everyday objects. You can't visualize an electron. You can't picture what it really looks like. Because at the quantum level, reality doesn't work the way your intuition expects. But, and this is Feynman's key insight, you can describe how it works. Write the equations, predict the outcomes, test the predictions, and they work. Perfectly. Quantum mechanics is the most successful theory in the history of physics, more precise than any other description of nature. And yet it defies intuitive understanding. Now comes the part that really turns everything upside down. Imagine a reporter asks Feynman, "Why does the universe exist?" You expect an answer, a theory, maybe brilliant speculation. But Feynman pauses and says something different. That might be the wrong question. Not because he doesn't know, but because the question itself reveals a fundamental confusion about what physical laws do. Here's what Feynman understood. Physical laws describe patterns, not purposes. Gravity says how masses attract. Electromagnetism says how charges interact. Quantum mechanics says how particles behave. Think of an apple falling. Why does it fall? Physics answers. The Earth's mass and the apple's mass attract. Newton's equation describes that. But why does gravity exist? Einstein goes deeper. Mass curves space-time. Gravity is geometry. But why does mass curve space-time? This is where physics stops. Not because scientists give up, but because you've reached the limit of where why works. It's like asking what's north of the North Pole. The question seems to make sense, but it doesn't. Feynman was brutally honest about this. Watch this. In a famous interview, someone asks, "Why do magnets repel?" Feynman replies, "Electromagnetic forces." The interviewer insists, "Yes, but why?" Feynman pauses and explains something crucial. You can ask why infinitely, but eventually you reach a point where the only honest answer is, that's just how the universe works. It's not unsatisfying, it's intellectual honesty. And then Feynman offers something more powerful than false answers. He offers better questions. Swap. Why does the universe exist? For, how does the universe work? That you can answer. And the answer is stranger than any creation myth. Look what you discover. Quantum mechanics. Particles exist in superposition until you measure them. Observation creates reality. Uncertainty isn't ignorance. It's a fundamental law. Relativity. Time and space are one fabric. Gravity is geometry. Nothing travels faster than light, not because it's hard, but because space-time's structure won't allow it. These descriptions of how don't need why to be profound. In fact, the how is more fascinating. Here's the twist Feynman understood. Accepting knowledge's limits is more revolutionary than pretending certainty. Stop chasing ultimate purposes. Look at real patterns and see what happens. Elegant mathematical laws govern the universe. No one invented them. They simply describe what happens. Complexity emerges from simple rules. Life arises from chemistry. Consciousness emerges from neurons. Symmetry in the equations. Patterns repeat at different scales. Beauty in the structure. Quantum mechanics doesn't tell you why electrons exist, but it shows how they behave. And that how is so counterintuitive, so mathematically precise, that you question what exist really means. Feynman loved this. He embraced the strangeness, the uncertainty, the mystery. He said, "I'd rather have questions that can't be answered than answers that can't be questioned." This is the answer that shatters your reality. Not an answer that closes the book, but one that opens up endless better questions. And see how much we still don't know. Why these specific laws? Why do these constants have the values they do? Why 3 spatial dimensions? No answers yet. Maybe never. But the search reveals extraordinary truths. Quantum gravity might unify relativity and quantum mechanics, show that space and time emerge from something deeper. String theory suggests particles are vibrations, that extra dimensions exist beyond what we see. Right or wrong, these ideas prove something. Better questions lead to deeper discoveries. And here's what matters. Not knowing why the universe exists doesn't leave you lost. It frees you. Free